Welcome back to our biomass class, where we're delving deeper into the fascinating world of conversion of biomass resources into heat and power. This video was made with the support of enlightening. Remember that this biomass energy course has 9 lessons. Lesson 3 has 3 main topics. This video is about agricultural residues. Agricultural residues are the residues generated by crop production. For example, straw, nut shells, or pruning residues. In this video, we will explain you how are they harvested and how can they be processed. There are different types of agricultural crop residues. In this video, we classify them in 3 groups. Field residues from annual crops, process residues, and residues from perennial crop plantations. Field residues are materials left in an agricultural field or orchard after the crop has been harvested. These residues include stalks and stubble, leaves, and seed pods. Process residues are materials left after the crop is processed into a usable resource. These residues include bagasse, molasses, husks, seeds, and roots. The cultivation of perennial crop plantations generate residues with 2 main activities: pruning during the production cycle and removing at the end of the production cycle. They could be considered as field residues, however their harvesting and processing differs from other annual crops like cereals. Let's start studying more in details field residues. Traditionally, the field residue has been plowed directly into the ground or burned in the field. In the past decades, new practices have been introduced to minimize the environmental impact of these practices. Additionally, the utilization of field residues as biomass to energy resources has been explored. Let's see an example of a field residue used as biomass for energy resource. Straw is an agricultural byproduct consisting of the dry stalks of cereal plants after the grain and chaff have been removed. Straw may be fed as part of the roughage component of the diet to cattle or horses. Straw is usually gathered and stored in a straw bale, tightly bound with twine or wire. Baling is made directly in the field during harvesting. The use of straw in medium to large-scale biomass power plants is increasing over time. The straw is either used directly in the form of bales, or densified into pellets that are burned in a boiler. More recently, torrefaction of straw with pelletization is gaining attention, because it increases the energy density of the resource, making it possible to transport it still further. Let's move to process residues. Agro-industry produces annually billions of tons of non-edible residues derived from the processing of crops. These residues can cause pollution, management problems, and economic problems. This is the reason for the development of different strategies to use agro-industrial residues as a source of value-added products. Under favorable circumstances, process residues can be easily used as biomass resource. For example, sugarcane bagasse is used to be burned to provide heat and electricity in sugar mills. Olive solid residues are used for energy production by direct combustion. Therefore, the lignocellulosic residues can be an economical input for the agro-processing industry. Let's move to residues from perennial crop plantations. Perennial crop plantations such as for coconut, olive, and grape generate considerable amounts of woody residues from pruning and replanting activities. In the same way as process residues, they have been traditionally considered an economic and environmental problem. Nowadays, they are gradually being considered as a potential to add value to the products. These crops generate residues with 2 main activities: pruning during the production cycle and removal at the end of the production cycle. Let's start with pruning operations. Pruning is a common practice that is generally carried out annually to ensure good fruit production. In this case, the residual biomass consists only in the twigs removed with the operation. This practice produces small volumes that are yearly available, During pruning, the branches of the year are cut and thrown on the ground along the row. The density of the material is always relatively low, and generally ranges from 1 to 4 tons of fresh substance per hectare, depending on the species and pruning intensity. The residue can be left in the field to dry naturally for a few weeks before harvesting. The most suitable machine must be chosen depending on the working conditions and the specifications of the energy conversion system. Harvesting represents in all cases a cost for the farmer. The cost of collection varies according to many parameters and can range between 15 and 70 euros per fresh ton. Transportation costs are also critical for the feasibility of conversion into biofuel for energy. Let's see what happens at the end of the production cycle. The biomass generated at the end of the cycle is made up of the entire plant, including the roots that must be removed. The frequency of replanting depends on many factors such as type of crop, intensity of cultivation, as well as unforeseen factors such as diseases or market needs. Broadly speaking, it can occur with a frequency of 15 to 30 years. Stems give a high yield of clean biomass. However, converting the stumps into biomass is more problematic. Felling can be done with a chainsaw, but the productivity of this operation is particularly low. Alternatively, it is possible to use modified shredders that cut and shred plants. However, this produces a low-quality biomass, which generally does not pay the cost of the operation. A simple but effective solution consists in using simple hydraulic shears blast chillers to be applied frontally to the orchard tractor. These harvesters cut and spread the plant perpendicular to the row with a low cost of about 100 to 160 euros per hectare, depending on the density and size of the plants. Whole plants can be left in the field for a few days or weeks to encourage natural drying. Given their reduced unit size and the complex shape of the plants, their handling is expensive. A system that collects and grinds them in a single pass is more suitable. The biomass produced in this way is of high quality and can sprout good market prices. Once the aerial part of the crop has been removed, the stumps remain to be extracted. This is a more complex job, but it can still lead to the production of interesting quantities of biomass capable of covering part or all of the costs of the operation. This is often done with excavators. However, this has poor productivity and high costs. For this reason, some manufacturers have developed dedicated equipment for this particular work niche. The stumps must then be removed from the field and, if possible, left a year outdoors. Once dry, the stumps can be shredded with machinery not sensitive to impurities. Biomass will have a lower market value than the wood chips produced with the aerial part. However, its low humidity could compensate for the inconvenience of coarse size and the inevitable presence of soil impurities. Wrapping up, biomass can be produced from agricultural residues. Productivity, costs, and biomass quality depend on how residues are managed and processed. Field residues include stalks and stubble, leaves, and seed pods from annual crops. Straw is an example on how these residues are harvested and processed to be converted into biomass fuels. Process residues include husks, seeds, bagasse, molasses, and roots left after the crop is processed into a usable resource. In that case, the lignocellulosic residues can be easily processed and converted to energy, becoming an economical input for the agro-processing industry. Perennial crop plantations generate residues during the production cycle and at the end of the production cycle. Pruning produces small volumes of biomass that are yearly available. The most suitable machine must be chosen depending on the working conditions and the specifications of the energy conversion system. The biomass generated at the end of the cycle is made up of the entire plant, including the roots. There are different techniques and equipment with different costs and productivity for removing plants and stumps. The biomass produced from the aerial part can be of high quality and can sprout good market prices. Conversion of stumps into biomass is more complex. However, it can cover the costs of the operation.